This project is taking a lot longer than I expected, so I'm going to cut an intermediary video now because the problems I've been hitting are reasonably interesting, I think. This project started out as an idea whilst I was building the lightsaber. I had to adapt my design to accommodate one of these. It's a push-pull potentiometer. Now I can take a pair of calipers and I can measure this and model it in CAD, and then I can take that positive model, boolean it away from the inside of my lightsaber, leaving a space for this to go. But whilst I was working on that, I thought, it's a shame there's not a simple way of roughly measuring the shape of these things. Which reminded me of some work that was going on at my university many years ago. But my university didn't have these available. This is a laser time of flight sensor. Now, my plan was relatively simple. It was to robotically position this time of flight sensor and move around the object taking measurements. I 3D printed a sort of turntable on a stepper motor and tested it with some sort of square faces at known distances. And I rotated this in front of the sensor and I couldn't make any sense of the readings whatsoever. The problem turned out to be the field of view for these time of flight sensors. So although I was measuring 2 or 3 centimeters away from this little thing, the field of view for that is about 25 degrees. And that meant that although I was getting some measurements from the shape, the spatial resolution of it as the object turns was very low. I looked around for better ones with a narrower field of view. I couldn't actually find any. If you're watching this video and you know of a laser time of flight sensor with a very narrow field of view, or a way of narrowing a field of view, I'd love to know in the comments. In the meantime, I've pushed on with a new approach, whereby I'm going to poke things. My first attempt to poke things, I wasted a good few days on this beautiful but completely impractical planetary gear system. That turned out to be impractical, so I went back to Raspberry Pi Pico, which is my new favourite microcontroller, wired up, and I built this little device based on a 4-bar linkage where when you push the end it clicks a micro switch shut when you touch something. And I can move that forward until it pokes something, and then I know how far it's moved, and that's the distance from the base point. The problem I was then having was that the force required to actuate even one of these little switches is actually quite heavy. I mean, I put weights on this and it got to about 70 grams before the little spring gave and the sensors clicked. So we went from time of flight sensor to a micro switch, and now I'm planning to use this. So what this is a little foot here. It's a little foot here that I press up and it breaks the beam on a photo interrupter. And I have my turntable. But I have a big powerful stepper motor down here, turning a very tall pinion gear. And then this table here has teeth around the outside and is mounted on a coach bolt. So as the stepper motor turns, this table moves very slowly, 1 millimeter per vertical per revolution, up the big gear until you get to the top. So if I mount something on this platform, I can move it up and down 1 millimeter per revolution, and I can move it round for, I don't know, at least 360 measurements around it. And I will use that helical path of measurements to produce a CAD model of what's inside it. At least that's the plan.